Bismillahirrahmanirrahim. Today we will study chapter 6 of our automotive technology course, and that is pertaining to the suspension system. And in this chapter, chapter 6, I intend to cover in 4 parts. The first part is mainly the definition, the basic concept regarding the suspension, and then the frames of a body we will discuss. So start with our basic slide of this course. We have covered the powertrain power flow diagram. Now we have come to the topic of suspension after the brakes, chapter 6. Now, what is suspension system? Suspension is the term given to the system of springs, shock absorbers, and linkages that connects a vehicle to its wheel. So suspension in general is a term given to the system of springs, shock absorbers, and linkages that connects a vehicle to its wheels. Serve a dual purpose, contributing to the car's handling and braking, protects the vehicle itself and any cargo or luggage from damage and wear. So suspension is generally we define is like this. And this is a link up in this chapter. Whatsoever I will cover, a very beautiful clip is covering all those aspects in this video. Now, general layout of the suspension system. If we talk about the front suspension, we start from the wheel. We have a steering knuckle here. Then we have a lower control arm. Then we have engine cradle or subframe here. Then this is your stabilization bar. Then we have a ball joint and steering knuckle arm. And then this McPherson stirrup and the steering gear. This is constitute the front suspension system. And in the rear suspension system, we have this spindle and the stirrup assembly and cross member and controls arm. We will study in detail all these assemblies or parts which I have laid out here. Now, generally, the front suspension of a vehicle is look like this. Now, purpose of the suspension system. The purpose of a suspension is to provide the vehicle with the following: a smooth ride, accurate steering, responsive handling, supports for the weight of the vehicle, maintenance of acceptable tire wear. Now, the purpose of the suspension is to provide the vehicle with the following: a smooth ride, accurate steering, responsive handling, support for the weight of the vehicle, maintenance of acceptable tire wear. The suspension principle. Suspensions use various links, arms, and joints. Suspensions use various links, arms, and joints to allow the wheels to move freely up and down. To allow the wheels to move freely up and down, front suspension also have to allow the front wheels to turn. So another duty for the front suspension system, despite the freely movement of up and down of the wheel, it has to cater for the front wheel to turn right or left. All the suspension must provide for the following supports. There are two types of supports. First one is the traverse or side-to-side wheel support. As the wheels of the vehicles move up and down, the suspension must accommodate this movement and still keeps the wheel from moving away from the vehicle or inward towards the center of the vehicle. So as the wheel moves of the vehicle moves up and down, the suspension must accommodate this movement and still keeps the wheel from moving away from the vehicle or inward towards the center of the vehicle. The control arm pivots on the vehicle frame. The wheels attached to the spindle that attach to the ball joint at the end of the control arm. Traverse links are also called lateral links. We will see this figure. First, let me read out the second sport. Longitudinal or front to back wheel sport. As the wheel of the vehicle move up and down, the suspension must allows for this movement and still keeps the wheel from moving forward, moving backward whenever a bump is hit. So first was the traverse or side to side wheel sport. The second is longitudinal front to back wheel sport. As the wheels of the vehicles move up and down, the suspension must allows for this movement and still keeps the wheels from moving backward whenever a bump is hit. Note in figure this how the separation of the pivot points where the control arm meets the frame provides supports to prevent front to back wheel movement. Let's see this figure. This is figure 112-29 means chapter 112 of and figure is 29. This green portion which we are seeing is the knuckle and this is the spindle. So this is green portion total its complete name is steering knuckle and this portion is known as the spindle and this portion is known as the steering knuckle. And this is the ball joint arrangement here and this is the upper control arm and this is lower control arm. So the spindle supports the wheel. So your wheel is here. This spindle supports the wheel and it's attached to the control arms with ball and socket joint called ball joint. So this spindle, which is part of the steering knuckle, is attached to the upper control arm and the lower control arm with the help of a ball and socket joints here at this position. The control arms attached to the frame of the vehicle through rubber bushing. Then this control arm is attached to the frame of the vehicle through the rubber bushings to help isolate noise and vibration between the road and the body. Remember one thing, whenever two metal parts are joined together, we have to have some rubber bushing or some material inside in it to minimize the noise or wear property there. So here we have a rubber bushing which helps to isolate the noise and the vibration between the road and the body. Now let's see this figure number 30. First, this is your upper control arm and this green portion is your lower control arm and this brown is your complete steering knuckle and here is the spindle where we have a wheel and then these rods are called the Stewart rod and then we have a coil spring and shock absorber here and the upper control arm and lower control arm and this is the upper control arm pivot shaft. So this Stewart rod provides longitudinal support to the suspension system to prevent forward and rearward movement of the control arm. So let's see, we have a wheel attached here. So this wheel is moving up and down. So this suspension system, this upper control arm and lower control arm is catering for your up and down movement of the wheel. And then this Stewart rod basically are providing the longitudinal support to the suspension system to prevent forward or rearward movement of this control arms. So the longitudinal, so this is pertains to this part. Now suspension design. The design of the suspension and the location of the suspension mounting points on the frame or body are critical to proper vehicle handling. It is very important how you design your suspension system and how the critical points in the suspension mounting are designed because the design of the suspension and the location of the suspension mounting points on the frame or body are critical to proper vehicle handling. Two very important design factors are called anti-squat and anti-dive. So these are two very important parameters or factors which we have to cater for while designing the suspension system. That is your anti-squat and anti-dive. What is anti-squat? The anti-squat refers to the reaction of a body of a vehicle during acceleration. It is basically when we accelerate the vehicle suddenly, the upper portion or the upper part starts to lift up, so that we have to avoid that lift up. So we have to design this suspension system so it is that anti-squat. The anti-squat refers to the reaction of the body of a vehicle during acceleration. It is normal in most design for the vehicle to squat down at the rear while accelerating. Most drivers feel comfortable while feeling this reaction even on the front wheel drive vehicle. Anti-squat refers to the degree to which this normal force is neutralized. So anti-squat basically refers to the degree to which this normal force is neutralized. If 100% anti-squat were designed into the suspension system, the vehicle would remain level while accelerating. So there will be no lifting of the front portion of the vehicle. So this is your anti-squat. Now, the other important factor or parameter which we have to cater for while designing the suspension system, that is the anti-dive. Anti-dive refers to the force that causes the front of the vehicle to drop down while braking. We are moving at a high speed and then we apply a brake. The front portion should not be having a dive. So there should a suspension system should be there to minimize or neutralize that the dive motion. So the anti-dive refers to the force that causes the front of the vehicle to drop down while braking. Some front nose dive feels normal to most driver. If 100% anti-dive was designed into a vehicle, it would remain perfectly level while braking. So first is the upper lift and second is the upper drag or downward motion. So we have to cater for both these motions while designing a suspension system. Now the functions of a suspension system: provides vertical compliance so the wheels can follow the uneven road, isolating the chassis from the roughness in the road. As I have explained, your wheel is moving up and down, so on the uneven road, so it's isolate the chassis from the roughness in the road. So vertical compliance is there. Then the second function of a suspension system is the wheels in the proper steer and camber attitude to the road surface. So steering geometry comes in the suspension system. The wheels in the proper steer and camber attitudes to the road surfaces. Third function is react to the control forces produced by the tires, longitudinal acceleration and braking forces, lateral cornering forces, and braking and driving torques. So it reacts to the control forces produced by the tires, longitudinal acceleration and braking forces, lateral cornering forces, and braking and driving torques. Fourth is the resist role of the chassis. Remember, in our last chapter, chapter 5, brakes, we have seen this diagram. This diagram. Roll is in your longitudinal direction, the x-axis, this P. So we have to cater for this. Resist roll of the chassis. Keep the tires in contact with the road with minimal load variation. So keeps the tire in contact with the road with minimal load variation. Now, first going into the details of the suspension, we have to talk about the frame or the body of the vehicle. So let's see the frame construction. Frame construction usually consists of channel shaped steel beams welded and or fastened together. So the vehicle frame, or we call it a chassis or a frame, or the body, the frame construction usually consists of a channel shaped steel beams welded and or fastened together. The frame of a vehicle sports all the running gears of the vehicle, including the engine, transmission, rear axle assembly if the rear wheel drive, and all suspension components. So the frame, the chassis, the body of the vehicle sports all the running gears of the vehicle, including the engine, transmission, rear axle assembly if the rear wheel drive, and all suspension components. Most trucks and larger rear-wheel driven cars use a full frame. So general types of frames are ladder frame, perimeter frame, space frame construction, sub-type frames, and unit body construction. So there are 5 types of frame. First one is the ladder frame. Then we have a perimeter frame, space frame construction, sub-type frame, and unit body construction. Now let's see the frame construction. The first one is the ladder frame. A ladder frame is a common name for the type of a parameter frame where the transverse lateral connecting members are straight across. When viewed with the body removed, the frame resembles a ladder. Most pickup trucks are constructed with a ladder type frame. So I read again. A ladder frame is a common name for a type of a perimeter frame where the transverse lateral connecting members are straight across. When viewed with the body removed, the frame resembles a ladder. Most pickup trucks are constructed with ladder types frame. So see, a typical truck frame is an excellent example of a ladder type frame. The two side members are connected by a cross member. So this is your side members, one side member and other side members, and they are linked with the cross members. So they are welded together like this. So this type of frame construction is called as a ladder frame. Now, rubber cushions used in the body or frame construction isolate noise and vibration from traveling to the passenger compartment. So we have a body and bodies placed on a frame. We have this cross members, side members, and we placed or isolate this frame from the body with the help of rubber cushions, rubber pads, to which not only isolate the noise and also the vibration from the road to the body and the passenger compartment. So this metal structure, when we join with this upper body or the hood, so we place rubber cushioning here, and the function of the rubber cushioning is to provide isolation of the noise and the vibration from the road to the passenger compartment. Now, the second is the perimeter frame. A perimeter frames consist of a welded or riveted frame members round the entire perimeter of the body. This means that the frame members provide supports underneath the side as well as for the suspension and suspension components. So second frame construction, second frame type is the perimeter frame. A perimeter frame consists of welded or riveted frame members around the entire perimeter of the body. This means that the frame members provide support underneath the side as well as for the suspension and suspension components. Now, third is the space frame construction. Space frame construction consists of a formed sheet steel used to construct a framework for the entire vehicle. The vehicle is drivable without the body, which uses plastic or steel panels to cover the steel framework. Space frame construction consists of a formed sheet steel used to construct a framework for the entire vehicle. The vehicle is drivable without the body, which uses plastic or steel panels to cover the steel framework. Fourth was the subtype frame. A subtype frame is a partial frame often used on a unit body vehicle to support the powertrain and suspension component. It is also called a cradle on many front wheel drive vehicle. I read again. Subtype frames. A subtype frames is partial frame often used on a unit body vehicles to support the powertrain and suspension component. It is also called a cradle on many front wheel driven vehicles. In figure this, a separate body and a frame construction, unitized construction, the small frame members, these are the small frame members, separate one, are for support of the engine and suspension component, Many vehicles attach the suspension component directly to the reinforced section of the body and do not require the rear frame section. Now, the last one is the unit body construction. Unit body construction, sometimes called unibody, is design that combines the body with the structure of the frame. So we join the body with the structure of the frame. The body supports the engine and driveline components as well as the suspension and steering components. The body is composed of many individual stamped steel panels welded together. So there are steel panels welded together with the body. Unit body construction, sometimes called unibody, is a design that combines the body with the structure of the frame. The body supports the engine and the driveline components, as well as the suspension and steering components. The body is composed of many individual stamped steel panels welded together. The strength of this type of construction lies in the shape of the assembly. So the strength of this type of construction lies in the shape of the assembly. The typical vehicle uses 300 separate and different stamped steel panels that are spot welded to form a vehicle body. So in general, the typical vehicle uses 300 separate and different stamped steel panels that are spot welded to form a vehicle body. Welded metal sections creates a platform that combines the body with the frame using unit body construction. So stamped steel panels are welded here with the help of spot welding, and 300 separate different stamped steel panels are used for construction of a general simple vehicle. Now, the platform. The platform of any vehicle is its basic size and shape. The platform of any vehicle is its basic size and shape. Basically, the platform decides or defines the structure or the shape of the vehicle. Various vehicles of different make can share the same platform, and therefore many of the same drivetrain, engine, transmission, and final drive components, and suspension and steering components. The platform of any vehicle is its basic size and shape. Various vehicles of different makes and types can share the same platform, and therefore many of the same drivetrain, engine, transmission, and final drive components, and suspension and steering components. The area separating the engine compartment from the passenger compartment is called the bulkhead. So this is your engine compartment and this is your passenger compartment, and this portion which is separating the engine compartment and the passenger compartment is known as your bulkhead. The area separating the engine compartment from the passenger compartment is called the bulkhead. The height and location of this bulkhead panel to a large degree determines the shape of the rest of the vehicle. So basically, this height of the bulkhead determines the shape and height of the vehicle. The height and location of this bulkhead panel to a large degree determines the shape of the rest of the vehicle. Track and wheelbase, very important factor while designing a suspension or a vehicle. Other components of a vehicle platform design that affects handling and rides are the track and the wheelbase of the vehicle. First one was the bulkhead, its design, its height, and the other are track and wheelbase. The other components of vehicle platform design that affects handling and rides are the track and the wheelbase of the vehicle. The track of the vehicle is the distance between the wheels. So if we are seeing the vehicle from the front or the rear, the distance between the two wheels is your track as viewed from the front or the rear. The track of a vehicle is the distance between the wheels as viewed from the front or the rear. Wheelbase of a vehicle is the distance between the center of the front wheel and the center of the rear wheel as viewed from the side. So while viewing the vehicle from the side angle, the distance from the center of the front wheel to the center of the rear wheel, that is your wheelbase. But if you are viewing from the vehicle from the front or the rear, the distance between the two wheels is called the track. So remember these two things. Another important factor which should be kept in mind while talking about the suspension or the frame or body construction, the unsprung weight. A suspension system has to be designed to allow the wheels to move up and down quickly over bumps and dips without affecting the entire weight of the car or truck or vehicle. In fact, the lighter the total weight of the components that move up and down, the better the handling and ride. This weight is called unsprung weight. So the suspension system has to be designed to allow the wheels to move up and down quickly over bumps and dips without affecting the entire weight of the car or truck or vehicle. In fact, the lighter the total weight of the components that move up and down, the better the handling and ride. This weight is called unsprung weight. The idea of very light weight resulted in magnesium wheels for racing cars, which are very light yet strong. Aftermarket wheels that resembles racing car wheels are often referred to as mag wheels. So magnesium wheel for the racing car are also referred to as mags wheel. Basically, it is the rim which we are talking about. For best handling and ride, unsprung weight should be kept as low as possible. Sprung weight is the term used to identify the weight of the car or the truck that does not move up and down and is supported or sprung by a suspension system. So, for best handling and ride, the unsprung weight should be kept as low as possible. Sprung weight is the term used to identify the weight of a car or a truck that does not move up and down and is supported or sprung by the suspension system. So with this, we comes to the end of our first part for chapter 6, that is the suspension system. In next part, we will talk about further regarding the suspension.